Good day, my viewers. Today is another day, and it is your regular host, Valentine. Today we'll be looking at, we'll be discussing the topic of indices. Indices. There's something I want you to all have or bear in mind. Indices has so many laws and rules. These are rules that will help you or help us understand how to solve problems on indices. These rules are like they are constant, or if I may use the word sacrosanct, in the sense that you need to abide by the rules so as to give you a better chance to solve questions and solve them correctly as long as indices is involved. So we'll look at the rules and we'll look at where it is applicable. The first law is this. As you know, we call this the base. So the first law says once the base, you have the same base, once the base are the same and there's multiplication sign in between, you add the powers together. You add the powers together. So you can see the example here, 4 raised to power 3 times 4 raised to power 7. That will be 4 raised to power 3 plus 7, which will give us 4 raised to power 10. In other words, we can liken this in the other version of it simply means once you do it this way, 4 times 4 times 4 times 4. So 4 raised to power 3. So I have to claim one of the 4s. So 4 raised to power 3 can be written as this 4 times 4 times 4. Then multiply by 4 times 4. So we need to write the other 4 7 times. I just want to show you the interpretation of this, what it actually means. Times 4 times 4. So let's count. 1, 2, 3, 4, 5 times another 4 times 4. So let's count all the fours all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in summary, this is 4 raised to power 10. Here, that's the interpretation of this. The danger of using this format, because there's danger associated to this. The danger of this is imagine your powers are, high value, maybe let's say 4 raised to power 21 times 4 raised to power, let's say 12. The danger to this is because once you have the powers in larger numbers, it will be difficult to start writing 4 raised to power 4 21 times, or 4 times 4 times 4 21 times. Then you continue with 4 times 4 times 4 12 times. It's time consuming, and in the end you might make mistakes. So that's the beauty of following this other shorter form of indices. So I will encourage my learners, please, and please do well to Do well to master this simple one, because the danger of this long one is if you have larger powers, it will be one time consuming and you might get confused, you might not know what to do. So, as mentioned earlier, I will encourage my learners to stick to this. This is a lot easier and less time consuming. I repeat, the first law says once you have the same base and there's multiplication sign in between, you just add the powers together. So in this case, this is 4 raised to power 3 times 4 raised to power 7. This will give us 4 raised to power 3 plus 7, which will be 4 raised to power 10. This is the first law of indices. Then the second one is a raised to power n divided by a raised to power n. So as you can see, this can still be written as this. They are virtually the same. One good thing about this examination awarding bodies, for instance, AQA, EduCards, Excel, there are so many examination awarding bodies. They are very good at confusing learners. So you need to outsmart them. So this can still be written as this. So the second law says once you have the same, I repeat, once you have the same powers and there's a division sign in between, once you have the same base, which is 12, the same base, which is 12, and there's a division sign in between, what you just need to do is to subtract the powers. So in this case, 12 raised to power 8 minus 3 will give us 12 raised to power 5. This is a lot easier. Then the third rule says once you have this, 7 raised to power 3 all in bracket raised to the power 5. It simply means you just multiply the powers and you move on. You get your answers and move on. As you can see this way, so this becomes 7 raised to power 3 times 5 will give us 7 raised to power 15. And repeat, you just need to multiply the powers all together. So in this case, this 7 raised to power 3 times 5 will give us 7 raised to power 15. Another thing you need to be aware of, just know that any number raised to the power 0 is 1. This has been proven, but for the sake of time and for the purpose of our level, we don't need to start solving this. Just know at the back of your mind that any number raised to the power of 0 is the same thing as 1. And again, any number raised to the power of 1 is still the same number. So I would like my learners to please patiently pay attention to details. Please, as mentioned earlier, this is just a revision guide to aid learning, to aid personal, to aid learning while in class, in a class setting, and also to aid learning while having a personal revision. So as always, as I always encourage my learners that should please take time, create time the same way you create time for television games, the same way you create time to visit friends. Please create time for your personal revision. That will help you to master any topic you are looking at. So, that being said, we'll move on to the next slide. Yeah, this is another rule, which is the negative powers. So what this simply means is any number raised to the power of negative sign, you need to write 1 divided by the same number to its power. So in this case, this is 5 raised to the power of negative 2. That becomes 1 divided by 5 raised to power 2, which is the same thing as 1 over 25. As mentioned earlier, you need to be careful, as they say a negative power can still have a positive answer. So what they are trying to say is you need to be careful in the course of solving problems involving negative power. So this is the fourth rule. Then the next rule is reciprocal. So reciprocal means you can see this. Remember, what this simply means is a raised to the power of 1. So what they are trying to say, normally in maths, any number or alphabet that starts on its own will always assume it's over 1. You can see, we always assume it's over 1. So what you just need to do, remember reciprocal, another reciprocal means you just need to twist, you need to flip. You can see once you flip this, you get this. So this simply means A over 1. Once you do the flip side, that becomes 1 over A. I repeat, A over 1. Because of this negative sign, you just flip it, so it becomes 1 over A. So what they are trying to say in essence is A to the power of negative 1 is the reciprocal of A. See? So what they are saying is this is the same thing as this, or vice versa. So A raised to power 1 is the same, is the reciprocal to this. So vice versa. So this simply means A over 1 is the same thing as saying 1 over A. So what's its the meaning is, since A over 1, you do the reciprocal, so it automatically becomes 1 over A. So in this case, you can see this is 5 raised to power 9, all brackets to negative 1. So you just do the reciprocal and you get this. Yeah, I understand you might, in the course of looking at problems, that's when you really understand what I'm trying to explain in this scenario. So let's move on. Let's move on to the next slide. So this is another law. So what this simply means is you can see this sign means 3 over 10 all bracket 3 all bracket to the raised to the power of 2. So this, for the fact that this bracket covers both the numbers on top and below, otherwise known as the numerator and denominator. This bracket, you can see it covers both numbers, all to the power of 2. So you can further break them to as 3 raised to the power of 2, 10 raised to the power of 2 is the same thing as 9 over 10. So in this scenario, it's quite different from this. Please, we need to be careful. You need to pay attention to these details. So, but in this scenario, it's quite different from this. This simply means it's only the power, it's only the number on top that's raised to the power of 2. So in this case, this becomes 9 over 10. Please, you can see the scenarios, they are not the same. So this, the number on top here, the numerator is only raised to the power of 2. So therefore, this is applicable to 3, which is the numerator alone. So please, my learners or my viewers, I will encourage you to learn to pay attention to details. So these are in two different scenarios. So let's move on. Then the second rule says combining rules, which it simply means is you can see this is 2 over 3 all bracket raised to the power of negative 3. So to do the reciprocal, once you change this, you remove the negative sign. You can see it is being flipped, or you do the reciprocal, it becomes 3 over 2, all brackets raised to the power of 3. As stated earlier, this bracket covers both the numerator and denominator, and it can be further broken down to this. So this becomes 3 raised to power 3 and 2 raised to power 3. Then once you simplify this becomes 27 divided by 8. So let's move on to the next slide. Oh yeah, that's it. So we'll be looking at some examples here. So we'll be looking at I will be looking at difficult examples. Then I will encourage my learners to have a go at the other exercises. So let's take this for example. Let's begin with this. So this is m raised to power 5. You can see the base are the same. There's a multiplication sign in between. So what you just need to do is to add the powers. So that will be 5 plus 3. That will be, your answer will be m raised to the power of 8. Same as this, you can see the base are the same. There's a division sign in between. So what you just need to do is to subtract the powers. You have to subtract the powers. So your end result will be m raised to the power of 6. Okay, m raised to the power of 6. So in this case too, as usual, so what you just needed to do is to multiply the powers together. Multiply the powers, so that will become 3 times 2, which will be m raised to the power of 6. So to solve this solution is the combination of question 1a and question 1b. So you need to apply these two rules into this question. So you can see m raised to the power 9 times m. So we can liken this by, if you like, so I would suggest you just add 1, because anything raised to the power of 1 is the same number or alphabet. So this becomes m raised to the power of 9 plus 1 divided by m raised to the power of 5. So this becomes m raised to the power of 10 divided by m raised to the power of 5. So your end result will be, you just need to subtract the powers. So that becomes m10 minus 5, which will become m raised to the power of 5. So this becomes your final answer. You can see question 2 has the combination of both these. So it's with constant practice you learn to appreciate when to apply the numbers, or when to apply the laws of indices. So one beauty about indices is you need to stick to the laws. Once you know the laws, solving the questions will be far more easier. So let's look at this one. This has been given from the previous example. As mentioned earlier, once anything has to do with the negative sign, this becomes 1 over 4 raised to the power of 2 which is the same thing as 1 over 4 raised to the power of 2 is the same thing as 16. That means 4 times 4 is 16. Then this. There are two ways of doing this, but we'll go for the shorter one. So in this case, this becomes just find the square root. This means square root. Just find the square root of 36, which will give us the square root of 36 is the same thing as 6. And this, remember, this will be, and this same thing is question 5. You get the cube roots. Cube root of 3, that will be the cube, find the cube root of 1000. So what this simply means is, what do you need to multiply by itself 3 times to give you 1000? So your answer becomes 10. So, for the sake of time, so I need to draw attention to these problems. Funny enough, I notice this is another confusion the examination awarding bodies are good at. So they might decide that, oh, since you know the laws of indices, they might want to confuse an individual, confuse you by giving you this. Please and please, this 5 raised to power 2 plus 2 raised to power 3 does not meet the standards and requirements of the laws of indices. Remember, I said one of the laws of indices, or the first multiplication law of the indices, is that the base must be the same. Once the base must be the same one, and there must be a multiplication sign in between. So what you need to do in that scenario is to add the powers. Choose one of the bases and add the powers together. But in this scenario, as mentioned earlier, exam as exam examination awarding bodies, they are very good at confusing learners. So in this case, what you just need to do is to solve straight. So 5 raised to power 2 is the same thing as 25, because 5 times 5 will be 25, plus 2 raised to power 3 means 2 times 2 times 2. So 2 times 2, 4. 4 times 2 is 8. So 25 plus 8 will give us 33. I repeat, this does not meet the standards or the criteria of the multiplication rule of indices. So in this case, just multiply straight. I deliberately brought this out because I've seen, or I've been privileged to mark assessment papers. I've seen this mistake. So learners might be confused and said, no, this is not the laws of indices. Yeah, they are deliberate. So you need to outsmart the examination awarding bodies. Please be careful, learn to pay attention to these details, because this does not meet this criteria. They are two different scenarios. This has to do with the laws of indices, but this does not meet the criteria. As such, you just need to solve straight the same way you do your mathematics. Likewise, this one too, this is the same thing. This does not meet the second rule, which is this square one. It does not meet this criteria. So this criteria says the the base must be the same. But in this case, there are two different base, and there should be a division sign must be in between. So in this case, you just pick one of the powers, then subtract you just pick one of the base, then subtract the powers. But this does not meet such criteria. As usual, what you just need to do is to solve straight. So you Ask yourself 3 raised to power 3 is the same thing as 27 minus 4 raised to the power 2 is the same thing as 16, which means 4 times 4 will give us 16, and 3 times 3, 9, 9 times 3 will give us 27. So once you subtract this, you'll be having 11. So I will leave this for my learners to have a go, or viewers. I'll leave this exercises so that they can have a go at it. There are loads of exercises in the next slides. Don't worry. I did not finish the questions. There are loads of them. So just have this, practice this too. Once you practice this, and this will give you, how will I say, this will give you that vibe in solving questions, or if I may use that word, this will set you in the tone or in the pace of solving questions on indices. So once you've done that, you can move on to the next slide. As usual, this is the answers. You use this slide to compare your answers to be sure if you are doing the right thing. So once you've done this, you can move on to the next slide. Also, there are loads of questions. So once more, I'm giving a shout out to Mass Genie. I got these resources from Mass Genie website. So shout out to them. So in this case, you just need to, okay, let me look at all these. They are similar to the questions in the previous slides. So I just need to, let me see if there are difficult ones I need to look at. So okay, let's see. Okay, let me try this. So okay, let's try this. This one is a lot complicated, but virtually the same as long as you understand. Okay, let's try this too. This, let's try 2b. Okay, let's try 2b. 2b is a lot, is similar with 1b. So let's try 2b. So in this case, what this simply means is every number and alphabet in the bracket should be raised to the power of 3. So to split this, I encourage my learners to break it down. So this is 4 times b raised to the power of 2 times c. So what you just need to do, so you need to multiply this to the power of 3, this 2 to the power of 3, this power of 3. So in this case, this becomes 4 raised to the power of 3 means 64. So b raised to the power of 2 times 3 will give us b6. Then you bring your c raised to the power of 3. Remember, this is 3 raised to the power of 3. So the solution to 2b is, your final answer becomes 64b raised to the power of 6, c raised to the power of 3. So I believe this is the complex one. Then we look at the same one last days. We look at this too. So you can see this means 12m squared n raised to the power of 6 divided by 3m n raised to the power of 4. In this case, this simply means 12 raised to the power of 12 divided by 3. You can see this is 12 and this is the division. So you need to divide the numbers. So 12 divided by 3 is 4. And you have m2. You have m2 Remember, this m is just 1, so that will be minus 1. Then n raised to the power of 6 minus 4. So your final answer becomes 4m and n raised to the power of 2. So this same thing as 4 raised to the power of 1. 4m, that's 4m raised to the power of 1. So it doesn't matter. You see, if you like, you put the 1, and if you like, you don't. They are still the same thing. So at this juncture, I'll limit myself to these two questions, we've solved. Then I will encourage my learners or my viewers to have a go at this. Once you've completed this, you can now go to the next slide to review your answers. So I will encourage you, please. It all boils down to constant practice. Once you practice, you stand a better chance to master this. So I will encourage my learners, please keep practicing. You need to just keep practicing. The more you practice, the more you get better. So let's see if we'll be able to cover another. Let's see if we'll be able to cover another topic. Yeah, this is the standard form. So in all summary, the summary of this page simply means for you to write the standard form. The standard form comes in this. The standard form comes to this, where your A, that's A times 10 raised to the power of n, where your A is a number between 1, where your capital A is a number between 1 and 10. 1 and 10. Why 10 raised to the power n tells us the number of places the decimal point moves. And your n, will say your n will be positive. Your n will be positive if the numbers or the question given is large. If the numbers is large, that means if the number is greater than 10, then your n will be positive. But your n will be negative if the numbers are less than 1. So please, you need to learn this. I repeat, A, the standard formula comes in this form, where your capital A will be numbers between 1 and 10 times 10 raised to the power of n. 10 raised to the power of n tells us the number of places the decimal point moves, and your n will be positive if the number is large, meaning if the number is greater than 10, and your n will be negative if the number is smaller, less than 1. We'll appreciate this once we crack on the exercises. So let's move on to the next slide. So I don't want to really waste our time on this. So rather, I will suggest my viewers to look at this slide, read, understand, and digest it. Then let's move on. Let's crack on our own part. Let's crack on. As usual, I will make attempts to, where's my cursor? I'll make attempt to solve this, and this, I will make attempt to solve it. Remember, your standard formula comes to this form. A times 10 raised to the power of n. So I will encourage my learners, once you have this solution written at a corner have this written just by the corner of the paper. So at least this will be like a guide, and to make sure that you are doing the right thing. Remember, your A must be numbers between 1 and 10. So in this case, so let's say this is a positive large number. Remember, as mentioned earlier, for instance, if you have 5 in maths, we assume there's always an invisible decimal point here because 5 is the same thing as 5.0. You agree with me that 5 is the same thing as 5.0. So for every positive whole number, we always assume that there's an invisible decimal point just in front of it, which need not to be written. So for mathematicians, we know that. So in this case, there's a positive number here because we want to put this in the standard form. So we have to count to the right we need to count to the right. So once we count, we need to count from the right to the left. So we will be moving towards this direction. So let's count. One, can see, two. You cannot stop here because it does not meet the criteria of the capital A. Three, you can't stop here because if you stop here, you get 35. Remember, the capital A must be numbers between 1 and 10. So, and this is 4. You can see we moved 4 places. So, at the end of the day, your answer is 3.5. You can see this meet the criteria of the capital A. Remember, A must be numbers between 1 and 10 times. You need to write this. It's constant. This is just like a constant number. You put this. Then you look at your N. N must be positive if the numbers is large or greater than 10. You can see this is 35,000. So we all you agree with me that this is larger than 10. And if you watch, we moved 4 places to get 3.5. So we moved 1, 2, 3, 4. So your N will be positive. Okay. Then let's look at this other one. Okay, let's look at this one. This one means write this as ordinary numbers. So this simply means this analysis of this means 1.2 times 1000 because 10 raised to power 3 is the same thing as 10 times 10. 100 times 10 is 1000. So to write this or to turn this to ordinary numbers, so you just need to move. You need to move. Remember the rules. The rule says once you have decimal number, multiply by either 10 or 100 or 1000. You move the decimal point to the right according to the number of zeros. According to the number of zeros. But if you have divided by 10, or you have this divided by 100, or divided by 1000, you move your decimal point to the left according to the number of zeros. So these are laws or rules you need to have at your fingertips when multiplying decimals by either 10, 100, or 1000. So let me permit me to clean that. Or okay, let me clean that and make space. So I just need to make space. So let me clean this to just to make space. So in this case, you have 1.2 times 1000. Reason 10 raised to the power of 3 is the same thing as 1000. So we move this decimal to the right. We'll be moving it to the right 3 times. So if you move this 1, 2, 3. Okay, let me write it here. So your answer becomes 1200. So from here, if you move it 1, 2, 3, you stop. So 1.2 times 1000 will give us 1200. So let's look at this too. As usual, I will not complete all because of time. So let's look at the complex ones. So let's look at this. So this simply means to solve this, you can say 4.7. Because of this negative sign, you can break it down. So that will be 1 over 100. 10 raised to power 2 is the same thing as 1 over 100. So once you multiply straight, so that will be 4.7 divided by 100, which is the same thing as this, which is the same thing as 4.7 divided by 100. As usual, you make reference to this. You can see the rules here. Can see the rules here. This is 4.7 divided by 100. So because it's divided by 100, we'll be moving our decimal point to the right according to the number of zeros. So 4.7 divided by 100 will be the same thing as, okay, let me write it here. We'll move this to the right, to the left according to the number of zeros here, which is 2 times. So that will be 1, 2. So let me write it down. 0.047. So remember the decimal point is somewhere here. So you move it to the left 2 times. So that's 1, 2. So your answer becomes 0.047. Now let's see. The question 3 says, which number is in standard form? You can see this does not meet the criteria because this has a, a plus sign in between. It has plus sign in between. So this is 5.5 plus 10 raised to the power of 8. No, you can't choose this. Remember, this is the standard form. This is the rules. So let's see this. This does not mean because your standard A, remember the capital A must be numbers between 1 and 10. So this is 36. 36 is greater than 10. So this does not meet the rule. So you can see this one too. Let's look at this. This, remember, your capital A must be numbers between 1 and 10. So, and this is below 1. So this does not meet the rule. Cancel. But in this case, this is perfect. 1. This is 6.5. It meets the criteria of A, where your A should be numbers between 1 and 10. And there's multiplication sign in it, and 10, you can see 10 is there and your n is positive, so you go for this. So I've solved 1a, 1b. This is unsolved. I've done 2B, and 3. So this will help my viewers or learners have a go at the other questions. Once you've attempted this, and shout out to Kobe Mass. You can see I used Kobe Mass to resources on this. Shout out to them. So once you've seen this, this will help you guide you to complete others. And once you've done that, you can move to the next slide to compare your answers. And once you've done that, if don't feel disturbed, for every correction you make, that is a learning point. Pick up from the corrections, correct yourself, and mark honestly. Once you've done that, you're on the path to self independency, and you will be getting better preparing for any forthcoming assessment or exam. So, as usual, I wish you all the best and keep practicing, because the more you practice, the more you get better. Remember, this is your friendly host and your regular host, Valentine. Thank you very much, and see you in the next session.